Good afternoon. Today we're going to finish up the notes on Chapter 21, Nuclear Chemistry. And we're talking about all the applications of nuclear chemistry. As you know, chemistry is everywhere and is everything. This first slide here is on transuranium elements. These are elements which have an atomic number above 92. They're synthetically produced in nuclear reactors and accelerators. Most of them decay very rapidly. At the bottom of the slide here, you can see transuranium elements in the purple. They're the ones above uranium 92. A question for you: which particle is utilized for making most synthetic isotopes and why? If you don't have that answer readily available, take a minute, research it in your textbook. Because the half-life of any particular nuclei is constant, the half-life can serve as a nuclear clock to determine the age of objects. The method of dating objects based on their isotope and isotope abundances is called radiometric dating. When carbon-14 isotope is used, then it's called radiocarbon dating. The half-life of carbon-14 is 5,715 years. On page 888 of your textbook, figure 21.7 goes through the creation and distribution of carbon-14. Has a nice illustration, goes through all the various steps. Please review that so that you have a good understanding of that concept. At the bottom of the slide is a link to a PhET simulation on radioactive dating game. Click on that, proceed through the activity, and to give yourself also a good visual of the concept. We are consistently bombarded by radiation from both natural and artificial sources. We're exposed to UV and infrared visible radiation from the sun, radio waves, x-rays from medical or dental procedures, radon. All of these forms of radiation fall into two categories: non-ionizing, which is not harmful to humans, or ionizing radiation, which is harmful. One particular molecule, the OH molecule, is a very unstable, highly reactive molecule. It's also called a free radical, which is a substance where one or more unpaired electrons. In cells and tissues, the hydroxyl radical can attack biomolecules to produce new free radicals, which in turn attack other biomolecules. Ultimately, it disrupts the normal operation of cells. Radiation doses include gray, rad, and REM. I have a question for you. What REM dose is fatal to most humans? If you don't have that particular answer off the top of your head, just read on page 905 and write that answer in your notes. Radon is a noble gas. It's an element that's found in rocks and in soil. And it's a noble gas, which means that it's not reactive, okay, unreactive. But what happens is if it's inhaled and gets into the lungs, it will decay and produce alpha particles, which can cause lung cancer. There are numerous applications of nuclear chemistry in the medical field. Radioisotope tracers are absorbed by specific organs and used to diagnose disease. Take 5 or 10 minutes and read Chemistry and Life Medical Applications of Radio Traces on page 893 of your textbook. Radio traces have found a wide use in diagnostic tools in medicine. Table 21.6 outlines that iodine 131 is used to treat thyroid, iron 59, red blood cells, phosphorus 32, eyes, liver, tumor, and etc. Read through the entire article on that page. It will also bring you down at the bottom to a PET scanner, which is a positron emission tomography. And I also, in the middle of this slide, click on View Animation. It's a short animation, but very informative. And lastly, radiation treatment. Larger doses are used to kill cancerous cells in targeted organs, internal and external radiation source. The picture at the right is radiation treatment using gamma rays from cobalt-60. Nuclear weapons is an effective but devastating application of nuclear chemistry. The diagram at the top left-hand corner shows a schematic diagram of the first atomic bomb used in warfare and dropped on Hiroshima, Japan on August 6, 1945. It uses a conventional explosive to bring two subcritical masses together to form a supercritical mass. Okay? Critical mass is the rate of neutrons lost equals the rate of neutrons creation by fission. So go through at the bottom of page 897 and read through subcritical mass, critical mass, and supercritical mass and its impact that it has with this application. The fission in the atomic bomb develops into an uncontrolled chain reaction. The hydrogen bond is a chemical explosion. It goes to fission and then fusion. Fusion increases the rate of fission. It's more powerful than the atomic bomb. Another series of applications of nuclear chemistry include food radiation, where radiation is used to kill bacteria on food like strawberries so that they'll last longer before going bad. We talked about radioactive tracers as it applies to the medical application, but they can also be used to explore chemical pathways or trace pollutants in water flow or study plant growth through photosynthesis. A consumer product we talked at the beginning of this unit a little bit about, ionizing smoke detectors, which utilize the isotope americium-241. Click on the link, How a Smoke Detector Works, to view an animation. Very interesting on the engineering involved in smoke detectors. If you've finished and copied the notes from this PowerPoint, your assignment for the rest of the class is number 1, browse the nuclear decay gizmo. You don't have to complete the handout with it. I just want you to browse it, answer the 5 assessment questions, but be sure you go through the gizmo so that this assessment will be graded. If you would like to have the handout, ask the substitute for the handout if you have difficulties, but you do not have to complete the entire handout, but it might help you along with the gizmo. So complete those 5 questions. Next is the gizmo half-life. This, the substitute will pass out the handout, and please complete both the handout and answer the 5 assessment questions under the gizmo. Both will be graded. Over the weekend, read sections 21.8 and 21.9. You don't have to do Cornell notes, but you do need to know the information there. And complete problems 53, 55, 57, 59, and 63. Monday we'll go over all of this information. We'll review, bring in any questions you need, because we'll have a test on chapter 21 only on Wednesday.